Python Lambda is an anonymous function which can take in multiple arguments but one expression. They are usually syntaxed in one line of code, making them easier to construct compared to the regular functions which can come in multiple lines of code. The downsides of using Python lambdas could be that they cannot handle nested conditional operations and similar cases. In today's video, we will cover basic concepts with Python lambdas with few examples. Stick around. I have opened up a Jupyter notebook where I have named this project Python Lambdas. Now, the basic syntax of a Python Lambda function is you have the Lambda keyword followed by the arguments, and then you have the expression, which is the code that is supposed to run, okay? Now, given an example, we can just say Lambda. Now, what do we want to do? We want to run a program that multiplies okay, let's start with basic addition. You have a value of x. So we want to add x to number 2 or any number we want to declare. So let's say x, okay? X here is the argument. And what is the expression? The expression will be x plus, we can just start with 2, okay? X plus 2. Okay, now if you're going to run it the way it is, you see that there's a function that has been created, but now an argument has not been supplied. Okay, now if we're going to supply an argument to this, to supply an argument to this Lambda function, we can just name this addition, maybe add. Okay, we can just call it add. All right. Now we can declare an argument and run it. So here it's saying 2 added to 2 gives us 4 because we declared 2. If you want to make this 3, if you run it to be 3 plus 2, which is giving us here 5. Similarly, we can replicate the same thing, but let's use multiple arguments in this case, which is x, y. So what do we want to do? We want to say, let's say we want to say x plus y. Okay. X plus y is the argument. Okay. X plus y is the expression rather. So now we want to supply an argument. So here there are 2 arguments, which is x, comma, y. So here x is 4. Let's make y 7. If you run it, you get 4 plus 7, which is 11. Okay. Similarly, we can use a multiplication operator. X plus 5, x multiplied by 5. Here we'll just say multiply, and let's call x maybe 3. So 3 multiplied by 5 here gives us 15. Now, these are basic ways to run scalar values with your Lambda functions. It's also possible to pick the same value here and just declare the argument directly without necessarily having to. Okay, let's go with this. All right, so we can just declare the argument directly and just give it the value and it runs directly. Secondly, we're going to look at list applications. Now, for list applications, the basic syntax will be the same way we have declared this. All of this here is what we call the function. So in the syntax for a list application, we call this list application. This first example is just a basic scalar application, because I'm applying this to scalar quantities. Now here, I want to apply a Lambda function to a list. And now when you are applying it to a list, either by filtering, actually there are more ways, but basically just two in this video. You can filter it, or you can run it as a map. All right. Now let's just give a basic example. If we have a list, okay. Now we're working on the filter example, and we have a list, a test list, for example, which is an array of numbers from 1 to 9. So here we want to write a Lambda function to filter out, let's say, the odd numbers in this list. So how would you run such a function? Let us take it step by step. Okay, let us write the function first of all, which is the lambda function. Now the argument here will be x, or any other argument you choose to use, followed by the full colon. Now what will be the expression? We want to test for, let's put a comment here. We're not testing, we're filtering. Filter for odd numbers. So our expression will be what? Now, think about it for a moment. The modulus operator, if you say x modulus 2, that means if it's an odd number, it will be equal to 1. Correct? So if the value of x is 3, 3 divided by 2 is 1, remainder 1. So it means whatever is the modulus will be equal to 1. So that is our expression. Okay? Now, that is our function. So what is our iterable? Because if you look at the syntax for filter, let me copy this out. So looking at the syntax for filter, which I've actually just pasted here, you will see that all we have done here is just to actually write the function. So to get the iterable, it means we'll say we'll add the iterable, and the iterable here is the test list, because we want to run through the test list. Okay, so now we are going to use the filter function to cover all of this. Okay, so basically whatever it is you're doing, you have to cover it with the filter. Okay, so but when you run this, you see that it has run the program, but it is at a certain memory. If you want to bring this out, you needed to have embedded it in a list. When you embed it into a list and you run it, you will see that what it does here is, out of this list you have here, this Lambda function is going to filter out. What will it filter out? It will filter out the true values of this. Okay, let me just show you something here. Now, if you run this, you see you get a false value. Okay, so x modulus of 2 equal to 1. So no, let me say this. So this is true because 3 modulus of 2 is actually 1, and 1 is actually equal to 1. But if this were to be 2 and you run this, it will be false. So a similar idea is applied here. So here, anything that's a true value is an odd number. Okay, so now it's going to filter out those numbers, and of course it's running through the test list, because the test list is the iterable. The test list here is the iterable. So it runs through the test list and filters out all the odd numbers. Voila. All right, same way we can apply this if we want to map out in the mapping syntax. Now we are going to be using the same test list, but there will be a slight difference. Same test list, but there will be a slight difference. Now, think about what we did in the filter syntax, okay? We ran we first of all let's start by declaring a lambda function. So now we've gone lambda, we've gone x, which is the argument. Now let us go into the expressions. Now, what are we exactly trying to do here? Let's say we want to take the power of maybe the square root of 2 of whatever x, the value of x is, okay? So what this is going to do is whatever value of x is supplied is going to take the power of 2, okay? So this whole values here, this whole code here is actually just the function, just like what you can see here in the syntax. We copy this out, paste it here, just for so looking at the syntax, we have clearly written out the function to be carried out, which is the lambda function. Now we are going to add the iterable, and the iterable here is our test list. All right. So what is left? Since in this case we are mapping the values, what do? We add the map to it. Okay, and of course, when you run this, it runs in the memory location. But if you want this to be visible, you actually have to apply it to a list. So here, any value you see in this list will be powered of 2. So which is the power of 2. So, but let's just change this here to maybe 3. Okay, let me just run this again. So you see, so it's going to say whatever value is fed into it. So it's going to take the third power. So when this is 1, 1 times 1 times 1 is 1. So here will be 1. When this is 2, 2 times 2 times 2 will be 8. So this is 8. When this is 3, 3 times 3 times 3 will be 27, and so on and so forth. All right. Another use case of the lambda among several others would be if we want to define a series object. Now, my first use case of this was writing a machine learning, drawing up a machine learning model, and then I had to import a certain database which was already preloaded into a model. And so there were certain columns I needed. So I needed to use Lambda to bring out these columns, okay? So now in this example here, we're just going to go with a simple data frame. In future examples, maybe in future machine learning series, which will be coming up, we'll be coming back to things like this. But here, let's just declare a simple Python data frame. Now I'm going to be talking about Python data frames in another video, so look out for that. But let's just define a simple data frame and data frame df. So now this data frame is simply a data frame of name, height, and birth year. So let's just say these are people and their height and their birth year. Now we want to run a lambda function that will calculate from this birth year. It will create another column and calculate, let's say, their age from the birth year. What do? Here we can apply, but if you're going to apply something, it means you're going to apply an actual function into this, an actual lambda function into this, okay? So in this case here now, we can say, let us declare the lambda function. And we say x is the argument, all right? Now, of course, you know, x is going to be all of these values here. It's going to be 1986, 1985, 2010, 2016. Each of them are values of x, okay? So here we've declared x. Now, if you want to check somebody's birth year, what is the most logical thing to do? You're most likely going to use the current year minus the birth year. So let's assume that the current year is 2022. You say 2022 minus x. I think that's basic enough to define the birth year. So all this goes into the apply function. Now, you want to read into a certain column, which is the birth year, okay? So this simply means you have to call out that column that column birth year. And when you call it out, you need to feed that value, all these values here, you need to feed it into another another column in the data frame. Now, this column can be easily created, which is the age. So what we're trying to do here is we want to create another column called age. Then we want to save each of the Lambda values into this new column. Okay, so you just say age is equal to all of this, and then so here, if you run df, you see that another column has been created called age, and the values have been populated accordingly. So that's it for today's video. Please don't forget to subscribe if you've not yet subscribed. It lets us know you appreciate what we're doing. Until our next video, I'll see you again. Bye-bye.